This set of videos is going to be a lot of short, kind of seemingly unconnected things, but when we put it all together with this new thing we're learning about area, it'll kind of make sense, and you might be able to make some connections with what we're going to do in the future. So the first thing is, I've seen this symbol before, right? The symbol with the kind of elongated S. I just called it an integrand. When we first talked about this had to do with antiderivatives. We're going to reuse this symbol again in a different way now. So now we have this integral, right? So this curve S symbol, but now we're going to put a number on the bottom and the top. All right, so this is the kind of starting point of our interval, and this is the ending point of our interval. And we have some function. And the way it's defined is this limit, which we saw in our last set of videos. This was called a Riemann sum, which was the area under the curve. So basically now this integral, when we put these values on it with no values, that's just saying take the antiderivative. When we start putting values on it, now this is saying find the area under the curve from A to B. So if we had some curve, we had A here and B here, we would just be looking for this area. That's what this notation would be saying. All right, and then there's one nice fact that goes along with this. If f of x is continuous, so remember continuous means you can draw the graph without lifting up your pen. If it's continuous, you can also do the integral, which also just means you can find any area you want. So I can find this area, I can find that area. All right, if my function is continuous, the area is gonna make sense. Like it's not a dispute about how high each of these sections is gonna be. All right, so we have this new notation, which is our old integrand notation, but now we put the kind of endpoints of our area. All right, this is gonna be the area under the curve.